Welcome to my first video on monads. This series is mainly directed towards students who have seen recursive programming in Haskell, recursive programming over lists, or perhaps more general algebraic data types. For students who have encountered monads and are now interested in understanding a bit the mathematical side of monads. On the other hand, I also think that mathematicians who don't really know about functional programming can pick up a lot of functional programming from following this. So the slogan for the first video here is monads axiomatise algebraic structure. Of course, the question then is, what is algebraic structure? So let me write this down, because that is really the question that will keep us going for quite a while. So what is algebraic structure? And at the end of the series, we'll be able to propose monads as a definition for what we mean by algebraic structure. But that will come at the end. So in order to get started, I think we need to look at examples of algebraic structure first. So the running example that we will use throughout this course is monoids, and we will look at it some detail in the next video. But before we go there, I think it would be a good idea to just look at some examples that are familiar to us. So first, maybe numbers, right? So numbers, we all learn about at school. And numbers provide us with many examples of algebraic structures. So we can take the positive integers with multiplication, or we can take the non-negative integers with addition, or we can take the integers with addition and multiplication and subtraction. We can take fractions, we can take real numbers, or maybe complex numbers. So these are already many examples of algebraic structure. Then in computer science, in programming, algebraic structures appear as data structures. So for example, lists are an algebraic structure that has operations in many different ways. So we can have head and tail of a list, or we can take concatenation, or we can take prefixing with an element. And there are other variations like stacks and queues. There are different disciplines for queues, like first in, first out, last in, first out. What else do we have? Automata, for example. Various automata can be seen as algebraic structures, where an input element is an operation that changes state. And then from programming languages, we have the idea of effects. So input-output, for example, or propagating of error messages, or changing of state, or non-determinism, or probabilistic effects can also all be seen as algebraic structure. So for the effects, maybe it's slightly less obvious what the operations and equations are. So let's just quickly think about it. For numbers, it's clear what operations and equations are, right? So addition, for example, is an operation, and we know that addition satisfies various equations, and actually we use these equations to do the computation with numbers. The same with data structures. Operations are really important. Actually, we know from the design of algorithms that a data structure is not just the way we represent data, but it is the operations we define on these presentations that really make a data structure into a data structure. And so for data structures, the equations are the specifications. The equations tell us how we have to implement the operations in order to satisfy the specification. And so for the effects, maybe just a quick example. Let's take input and output. So for example, if we first print A and then we print B, then that will be different from doing it the other way around. But on the other hand, if we give a choice between A and B, then offering the choice of A and B should be the same as offering the choice of B and A. So also with effects, we see that we will have different equations. So what all of these examples have in common, so we have seen numbers, and then we've seen data structures, and then we've seen effects. And what all of these examples have in common is operations and equations. So maybe that's our first answer to the question of what is algebraic structure. So algebraic structure, still quite informally, is about operations and equations. So in the next video, we will take one particular algebraic structure, monads, and look at it in more detail. And then we're going on to study different monads in the programming language Haskell and from the point of view of mathematical notation. Thanks for watching.